Hi guys, today's notes are on 7.5a. This is our first day of solving rational equations. So first off, please make sure equations have an equal sign. Okay, it might have the direction solve, but it could also not. Like usually I'll tell you. Okay, remember that rational equations are equations with a variable in the denominator. That's what makes it rational. Okay. And step one, we're actually going to do that tomorrow. So I'm going to say C 7.5b notes. I'm going to cross this out. Okay. So if you guys take a look at example 1, this might look really familiar to you. We've been doing a lot of these problems on warm-ups already, and hopefully that rings a bell of cross multiplying. So if you have one rational expression equal to another one, then you can cross multiply and solve for x. Okay, well, let's do it. So we're going to check there's an equal sign, and then we're going to cross multiply. Okay, and I like to write this all out. So I'll have 2 parentheses 2x minus 7, and then on the other side I'm going to multiply 5 and x plus 8. I like to write this step so I can make sure that I distribute correctly. So you guys always get 2 times 2x, right? That's 4x. The one people forget is this second one, so I'm just going to highlight that one here. Minus 14 equals to 5x, and then 5 times 8 is 40. If you are someone that tends to forget that step, please, please, please say it to yourself every single time. At this point, you want to get all of your variables on one side and all of your numbers on the other. I like to do x equals numbers just to be consistent. I'm an Algebra 1 teacher at heart. Okay, so it was easier for my students if I always move x to the left and I always move numbers to the right. Sometimes sign-wise, it's better to do it the other way, but for right now, let's start this way. Okay. Oops, sorry, that's the opposite of what I just said I would do. So sorry. Let's fix that. Okay, I'm going to move the 5x to the other side. Sorry about that. My other step was actually acceptable though, right? So it's just, I'm going to be consistent with what I say I'm going to do. Okay, because once you see this, then you can add 14 and add 14. I always move my x's first so I don't get confused at the end what to do with my x's. Okay, last step, divide by -1 or switch all the signs. And we get x equals 54. Okay. And so far that's where we've stopped, but there's one more step now that we have to look out for. Step 3 is that we know that we are going to check our solutions. Oops. By identifying restrictions. Because we know now that there cannot be denominators cannot equal to 0, right? These are my restrictions, which are values that make, let's write this down here, denominators equal to 0, also known as restrictions. And these are solutions that are called extraneous, if you remember from our previous chapters. Extraneous because fractions cannot be divided by 0. Okay, so I'm going to check what my restrictions are. We know that x cannot equal to -8. And then if there was no 2 there, we know it'd be +7. But since we are multiplying by 2, we have to divide by 2. Well, check them. Do they apply? In this case, no. So x equals 54 checks out. Okay. So why don't you right now try your u-try. You're going to cross multiply and see what you get. Okay. I'm going to pause the video here and then I'll show you my answers in just a second. Okay, so take a look. If you solve correctly, please make sure you distribute 2 to 2, which is 4. Subtract to both sides. Negative and a negative becomes more negative when we're adding. And please check your restrictions. I know you guys are really good with this one. Negative 2 plus 2 is 0. And then this one, if there's no number, it just means 0, right? So no number is 0. Okay, let's try example 2 now. If there's no second fraction, you can always make your own fraction by multiplying by 1. Okay? And then this ends up being exactly the same. See if you can do this problem as well. I'll keep writing. Okay, so I'm just gonna work without talking here. You keep working as well. Check your answers occasionally. Okay. When you get there, I think you're going to get x equals negative 2, which normally we would box and say this is done, but please check the restrictions here. X cannot equal to negative 2. What do we do about the 1 in the denominator? Well, there is no variable there, so there's no restriction. Okay, restrictions only happen when we can plug something in. Like if we took negative 2 and put it here, like that would not be 0, right? There's nowhere to plug it. So that 1 is going to stay no matter what. Well, if this is the case, then this is not a solution, right? So this one is an extraneous solution, but what I want you to write overall for this problem is that there is no solution. And you have to write the words no solution, not extraneous, because it's possible to have one extraneous solution and still have a solution, right? We could have two, and one of them cancel out, but the other one doesn't, okay? So let's try the u-try. We're going to do this the same way. I'll keep writing, but ideally you would try this on your own without looking at the video. Actually, let me pause the video. You guys do the work, okay? So I want you to pause here. Okay, at this point you'll notice that we have x squared and x's. So we are going to move the x squared and x's to the other side. But when you have an x squared, we want to set equal to 0. Because if we set it all equal to 0, then I can factor, right, what multiplies to 4 and adds to the middle 4, which will be x plus 2 equals 0. I'm going to rewrite that as x plus 2 squared, okay, because I don't need to write it twice. So final answer is x equals negative 2. There's only one of them. Technically there's two, right? Repeated solutions. Let's check our restrictions. X cannot equal to negative 1 and 0. You cannot do the check in your head, so please show me that you check the restrictions. Okay. Example 3 and u-try 3 are our last two problems. It starts off exactly the same. I'm going to cross multiply. But some students will take this shortcut where they tell me x times x and 1 times 6. You don't just multiply like terms. You have to distribute your x times x, but you also have to distribute x times negative 6. And then we're going to go 1 times x and 1 times negative 6. Okay, you try the right side on your own. See if you can get your common denominators there, or sorry, your FOIL or distribute. So at this point, I'm going to try to move all the x's to the left. You could also combine like terms if you wanted to. Okay, so your choice. This is a positive, so be really careful there. I'm going to draw the line just to show what's on the left and right. Notice that these two cancel out. I'm also going to minus 2x plus 3x, right? These all cancel. And I get, if I combine negative 6 minus 2 is negative 8 plus 4 is negative 4. Okay, And then now all I have to do is add 6 to both sides. Negative 4x equals, and that's also 0. Now, don't tell me this is no solution, because 0 divided by a number is allowed, and that gives me x equals 0. Okay, let's check our restrictions. X cannot equal to 3 and 6, so we are good to go. Okay. Why don't you get started on the last problem, practice it, and let's see if you can get the same answer as me. Okay, at this point, we want to recognize before we do anything, even a times c double GCF, we do want to factor out and get rid of this negative. We never want the first number to be negative. If I do this, I get negative 1 parentheses 2, x squared minus 7x minus 15 equal to 0. And now we're going to do a times c double GCF. Okay. Now, what does this negative 1 do? The negative 1 goes away. Okay. So let's do my a times c on the side here. That'll be negative 30, 2 times 15, right? And then negative 7. So those two numbers will be negative 10 and positive 3. Please do not just like write 2 parentheses from here. It's not that simple. We have to do 2x squared minus 10x plus 3x minus 15. I'm going to double GCF. I know it's getting a little cramped. It'll be okay. Check the signs on this. Since the first one of both GCF problems are positive, we know we want positive. Okay, so at this point, I know that these 2x plus 3 are going to go together. I'm going to check to make sure that I get the same thing when I divide, right? 2 divided by 2 is 1. And negative 10 divided by 2 is negative 5. I do need to check this side. 3 divided by 3 is 1, and negative 15 divided by 3 is negative 5. Okay? From here, I know that x equals, change your signs, positive 5, and this one will be negative 3 over 2. We'll check our restrictions. We know x cannot equal to positive 3. This one, yikes. If I had to set this equal to 0 and solve, I would add 27 to both sides, right? And then we'd have to square root both sides. So this means that x cannot equal to positive or negative square root 27, but that's not a problem. Okay, so here are my solutions still. That concludes today's lesson. Please practice your homework.